High above the dusty plains of Mars, a silent and invisible menace stirs. It starts with a whisper, the faintest shift of the crimson sands, a subtle haze creeping over the horizon. What begins as a gentle breeze soon transforms into a howling tempest, carrying with it trillions of tiny particles that can blanket the entire planet. These are the infamous Martian dust storms, a force of nature both beautiful and terrifying. Unlike the storms we know on Earth, with their thunder and lightning, Martian dust storms bring an eerie stillness. They cloak the landscape in an endless orange twilight, blocking the sun's life-giving rays and plunging temperatures into bone-chilling cold. To the casual observer, Mars may seem like a quiet, barren world. But when these storms rage, Mars becomes a dynamic planet, one where the wind sculpts the landscape, reshapes dunes, and challenges every mission that dares to explore its surface. These storms aren't just a curiosity. They are a fundamental part of Mars' climate and history, shaping its environment over billions of years. For future explorers, both robotic and human, they present one of the greatest threats, testing our ingenuity and resilience in the harshest conditions beyond Earth. To understand Martian dust storms, we must first understand the planet's surface itself. Mars is often called the Red Planet, a name derived from the iron oxide, or rust, that coats its soil and rocks. This dust is incredibly fine, microscopic grains so light that a whisper of wind can send them swirling into the thin atmosphere. Billions of years ago, Mars was a much different place. Rivers carved valleys, lakes filled basins, and perhaps even oceans stretched across its surface. Over time, as the planet lost much of its atmosphere and water, the landscape dried and fractured. Meteoroid impacts and volcanic activity pulverized rock into the dust we see today. This fine material is now everywhere, on the ground, suspended in the air, and carried across vast distances by persistent winds. But Martian dust is more than just dirt. The particles are electrostatically charged, meaning they cling to surfaces like static Klingon clothing. This makes dust accumulation a persistent problem for equipment. It coats solar panels, obscures cameras, and infiltrates seals and joints. For a planet where energy and precision mean survival, dust is a silent adversary. Mars' atmosphere is incredibly thin, less than 1% the density of Earth's, so you might expect its weather to be mild. Yet, paradoxically, this thin air and dry environment set the stage for some of the most extreme dust storms in the solar system. The storms start small, local whirlwinds called dust devils that twist up columns of dust across the Martian plains. These tiny twisters can grow dozens of meters high, dancing across the landscape like fiery tornadoes. Sometimes, multiple dust devils combine or expand, their rising columns of dust heating the surrounding air. This heating creates convection currents, lifting more dust and warming the atmosphere further. The dust acts like a blanket, absorbing sunlight and distributing heat unevenly, which in turn drives even stronger winds. A positive feedback loop is created. What started as a small disturbance escalates into a full-blown storm. These storms vary widely in scale. Some are localized and last a few hours. Others grow to engulf entire regions. And on rare occasions, a planet-encircling storm emerges, wrapping Mars in a global haze that can last for months, darkening the entire surface beneath. Mars exploration began with robotic pioneers, rovers and landers sent to brave the hostile environment. These mechanical explorers have transformed our understanding of the planet, sending back stunning images and invaluable scientific data. But dust storms have proven to be a formidable obstacle. Most rovers rely on solar panels for power. When dust fills the air and blocks the sun, energy levels plummet. The solar arrays themselves can become coated in dust, further reducing efficiency. The 2018 global dust storm was a devastating example. NASA's Opportunity rover, a workhorse of Martian exploration for over 14 years, was caught in the storm's grip. For weeks, the sun was obscured and Opportunity's batteries drained. Despite attempts to revive it, the rover fell silent, a poignant reminder of the storm's power. Other rovers like Spirit and Curiosity have faced similar challenges, although Curiosity's nuclear power source shields it somewhat from dust-related power loss. Still, dust accumulation on cameras and instruments continues to complicate operations. The threat is not just power loss. Dust can interfere with mechanical joints, sensors, and communication equipment. Each storm tests the limits of engineering and the ability of mission teams on Earth to adapt quickly. Looking to the future, Mars is seen as the next great frontier for human exploration. But Martian dust storms pose unique and serious risks to astronauts. Unlike robotic rovers, humans need more than machines. They need life support, shelter, food, and clean air. Dust storms could darken the skies for days or weeks, disrupting solar power generation and forcing astronauts to rely on backup systems. Visibility will plummet, making surface navigation and extravehicular activity dangerous or impossible. Perhaps more concerning is the dust itself. These fine particles are not only abrasive, but may be harmful if inhaled. Mars dust contains perchlorates and other chemicals that could be toxic. Inside habitats and suits, dust infiltration could damage filters and breathing apparatus, posing long-term health risks. Astronauts will need strict protocols to prevent dust from contaminating living spaces. Spacesuit design, air filtration systems, and decontamination chambers will be crucial. The challenge is not only to survive the storm, but to live with dust as a constant companion. Despite the dangers, scientists and engineers are working tirelessly to prepare for Martian dust storms. One key strategy is energy diversification. Nuclear power sources like radioisotope thermoelectric generators, RTGs, can provide continuous energy regardless of sunlight, ensuring habitats and critical systems remain operational during storms. Solar power may still be used, but with redundancy and dust removal technology. Innovative solutions include electrostatic dust cleaners that repel or shake off dust from solar panels and sensors. Robotic rovers and habitats may be equipped with brushes or vibration systems to clear accumulated dust. Advanced weather monitoring from orbit and surface stations will help predict storms hours or days in advance. This will give astronauts and mission control time to take protective measures, sheltering equipment, adjusting schedules, and conserving resources. Moreover, scientists are exploring ways to harness the very nature of dust storms. Could the static electricity generated by dust movement be captured as an energy source? Could dust particles themselves be used as raw material in in-situ resource utilization? The challenge is immense, but so is human ingenuity. Global dust storms occur every few Martian years, each lasting several weeks to months. They transform Mars from a vibrant landscape into a planet cloaked in orange twilight. These storms remind us that Mars is not just a cold, barren rock, but a world with complex weather systems still not fully understood. Scientists continue to study these storms using orbiters like Mars Reconnaissance Orbiter, surface rovers, and atmospheric models. Understanding the triggers and dynamics of dust storms is essential for planning long-term missions and settlements. Future colonies must be designed to survive and thrive despite these harsh conditions. As we set our sights on colonizing Mars, the dust storms stand as a powerful symbol, both of the planet's unforgiving nature and the resilience required to become interplanetary explorers.